What if the universe isn't just an empty, silent expanse of stars and galaxies, but a living, thinking entity, aware of its own existence? It sounds like science fiction, but some of the brightest minds in physics and philosophy are seriously considering this possibility. Today, we're diving into one of the most mind-bending mysteries of all, the idea that consciousness might not just be a product of the universe, but woven into its very fabric. Welcome to the frontier of quantum consciousness, where the lines between mind and matter blur, and reality itself might be more alive than we ever imagined. Think about the last time you marveled at the night sky. Those distant stars, the vastness of space. It feels impersonal, indifferent, but what if that's an illusion? What if, at some fundamental level, the universe isn't just a cold machine governed by equations, but a dynamic, interconnected web of awareness? This isn't just poetic speculation. From the strange behavior of quantum particles to the eerie similarities between neural networks and cosmic structures, there's mounting evidence that consciousness could be a cosmic phenomenon, not just a human one. And if that's true, it changes everything. Over the next 30 theories, we'll explore ideas so radical they'll challenge your understanding of reality. Could black holes be cosmic minds? Is the universe computing its own existence? Does consciousness collapse quantum probabilities into the world we see? Buckle up, this is more than a journey through science. It's a voyage into the unknown where physics meets philosophy, and the very nature of existence is up for debate. Whether you're a skeptic or a seeker, one thing's certain: by the end, you'll never look at the cosmos or your own mind the same way again. What if every particle in the cosmos is a tiny thought in the mind of the universe itself? This first theory takes us straight to the edge of scientific speculation, where the universe isn't just a collection of objects, but a vast thinking entity. Imagine the quantum realm, where particles can be in multiple places at once until observed. Now scale that up. What if the entire cosmos exists in a haze of possibilities until some form of universal consciousness chooses one? It's not as far-fetched as it sounds. Nobel Prize-winning physicist Roger Penrose suggests that consciousness might emerge from quantum vibrations in microtubules, tiny structures inside our brain cells. But here's the leap. If quantum processes can birth awareness in our skulls, could the same rules apply to the universe at large? Think of quantum entanglement, that eerie phenomenon where particles instantly influence each other across vast distances as if space doesn't exist. Now picture those entangled links forming a cosmic neural network, with galaxies and black holes acting like nodes in a brain trillions of light years wide. Some researchers argue that the universe's structure mirrors the human brain's neural pathways, with filaments of galaxies resembling axons and dendrites. If nature repeats patterns at every scale, why not consciousness too? The universe might not have a mind, it might be one, a self-organizing system where quantum ripples are its thoughts. This idea flips traditional physics on its head. Instead of consciousness being a fluke in an indifferent universe, it becomes the engine of reality. Every collision of stars, every ripple in space-time could be part of a vast computation, a universe not just existing but thinking itself into being. It raises wild questions. Are black holes cosmic memories, swallowing information only to re-emerge elsewhere? Is the Big Bang the universe waking up? We don't have answers yet, but the clues are there, written in the quantum code of reality itself. If every particle hums with a whisper of awareness, then consciousness isn't something the universe creates, it's something the universe is. This is the radical heart of panpsychism, the idea that even the tiniest building blocks of reality possess a flicker of subjective experience. Not full-blown thoughts, of course, but a raw, primal form of feeling proto-consciousness. Combine this with quantum physics and the implications become staggering. At the quantum level, particles don't just exist in fixed states, They hover in clouds of probability, reacting to observation in ways that eerily resemble choice. What if that's not just random behavior? What if it's the faintest murmur of something like mind? Take electrons, for example. They don't behave like tiny billiard balls. They dance, they interfere with themselves as if testing all possible paths before deciding where to appear. Panpsychists argue this isn't just mathematical abstraction, it's the signature of a rudimentary inner life. Imagine a spectrum of consciousness stretching from the faint hum of a quark to the roaring symphony of human thought. In this view, complex awareness isn't conjured from nothing by brains. It's assembled from countless tiny pulses of experience, like neurons lighting up in a cosmic network. And here's where it gets wilder. Biology might be proving this right. Recent experiments have detected signs of quantum coherence, those delicate, interconnected states usually associated with supercooled labs inside warm, messy living cells. Photosynthesis, for instance, relies on particles that seem to explore multiple energy paths at once, almost like they're calculating the most efficient route. Even bird navigation hints at quantum-aware biology, with entangled particles in their eyes acting as tiny compasses tuned to Earth's magnetic field. If nature harnesses quantum weirdness for survival, could consciousness be another emergent layer of this quantum choreography? The implications ripple outward. If even atoms carry a whisper of awareness, then the universe isn't a dead machine. It's a vast, shimmering field of potential experience. Stars wouldn't just burn, they'd feel their own nuclear fires in some ineffable way. Black holes might not just warp space, they could be cosmic vortices of transformed consciousness. This isn't mysticism, it's a frontier where physics and philosophy collide. As one researcher put it, we don't need to explain how matter generates mind. Mind was there all along, hiding in plain sight. The real mystery isn't why we're conscious, but how particles conspire to turn their tiny whispers into the roaring chorus of a self-aware universe. Picture the inside of a brain cell, a microscopic world buzzing with activity. Deep within, tiny structures called microtubules act like scaffolding, holding everything together. But what if these microtubules are doing far more than just providing structure? Enter Stuart Hameroff and Roger Penrose's Orch-OR theory, one of the most provocative ideas in consciousness research. They propose that these microtubules aren't just passive tubes, they're quantum processors vibrating at frequencies that could give rise to conscious experience. And here's the twist, this might not be limited to human brains. If quantum vibrations can collapse into moments of awareness inside us, could the same process be happening on a cosmic scale? The theory hinges on a quantum phenomenon called objective reduction. Normally, quantum particles exist in multiple states at once, a blur of possibilities until something forces them to choose a single outcome. Penrose argues that gravity itself, warping spacetime at the tiniest scales, causes these quantum states to collapse. Now pair that with Hameroff's insight, microtubules in brain cells could be orchestrating these collapses, turning quantum fuzziness into sharp, coherent moments of consciousness. It's like a symphony where each note is a flicker of awareness, and the conductor is the fabric of reality itself. But here's where it gets cosmic. If space-time geometry is fundamental to this process, then consciousness might not be locked inside skulls. The entire universe could be humming with similar collapses, quantum ripples in the structure of reality, birthing fleeting moments of experience everywhere. Imagine black holes or even empty space undergoing their own versions of objective reduction, not as thinking entities, but as echoes of the same quantum choreography that lights up human minds. Of course, Orch-OR has its skeptics. Critics argue that the brain is too warm and wet for delicate quantum states to survive long enough to matter, like trying to play a violin concerto in a hurricane. Yet, recent experiments have found hints of quantum coherence in biological systems, from photosynthesis to bird navigation. suggesting nature might be sneakier with quantum effects than we thought. Some researchers even propose that quantum vibrations in microtubules could explain near-death experiences, with consciousness persisting briefly after clinical death. Whether Orch-OR holds up or not, it forces us to ask a profound question. If consciousness emerges from the deepest layers of physics, could it be a universal phenomenon woven into the cosmos since the Big Bang? The idea that our thoughts might be quantum echoes of spacetime itself is dizzying, but in a universe this strange, maybe we shouldn't rule it out. After all, if the boundary between mind and matter is thinner than we imagined, reality might not just contain consciousness. It might be consciousness unfolding one quantum collapse at a time. What if the thoughts in your head aren't just yours but entangled with minds across the universe? This theory takes quantum strangeness to a breathtaking extreme, suggesting that consciousness itself might be woven together through the same spooky connections that bind particles light years apart. Quantum entanglement, where particles mirror each other's states instantly no matter the distance, is already weird enough. But what if human minds, or even all conscious beings, are tapping into this cosmic network? Consider the Global Consciousness Project, a decades-long experiment that's recorded eerie statistical glitches in random number generators during major world events. From natural disasters to royal weddings, these machines spread across the planet suddenly deviate from randomness at moments of collective human focus, as if the weight of millions of emotions briefly warps probability itself. Skeptics call it coincidence, but proponents see a fingerprint of entangled awareness, a hint that our minds might be whispering to each other through quantum channels we don't yet understand. Now stretch that idea further. If entangled particles defy space, could two people sharing a deep bond, twins, lovers, even strangers in sync, momentarily bridge their consciousness through quantum links? There are tantalizing, if controversial, studies. In one experiment, pairs of meditators separated by miles showed synchronized brainwave patterns during focused connection, despite no physical or sensory contact. Another found that people could feel being stared at from behind with statistical significance, as if attention itself tugged at some invisible thread. The implications spiral outward. Ancient traditions speak of the Akashic records or a universal mind. Could these be metaphors for a quantum-entangled layer of shared experience? Even modern physics toys with holographic principles, where information about the whole universe is encoded at its boundaries, accessible from anywhere inside. If consciousness is quantum at its core, perhaps we're all nodes in a vast, living web, exchanging more than we realize beneath the surface of ordinary reality. Of course, the leap from particles to people is enormous. Critics argue there's no known mechanism for brains to sustain entanglement in warm, noisy biological systems. Yet, nature keeps surprising us, like with quantum effects in photosynthesis or bird navigation. If biology already exploits entanglement, why not consciousness? Maybe we're not separate observers at all, but ripples in a single, universal sea of awareness, fragmented only by the illusion of individuality. As one physicist mused, the universe isn't just interconnected, it might be a conversation. And we're all part of the dialogue, whether we know it or not. What if the universe we perceive, with its galaxies, oceans, and beating hearts, isn't the full story, but a three-dimensional projection of something far stranger? This theory plunges us into the holographic principle, a radical idea born from black hole physics that suggests reality might be like a cosmic movie screen, with all the information needed to construct our world encoded on a distant, two-dimensional surface. But here's the twist: if the universe is a hologram, could consciousness be the projector? The math behind this is both elegant and mind-bending. When physicists study black holes, they find a paradox. The information swallowed by these cosmic voids seems to vanish, violating quantum laws. But in the 1970s, physicist Jacob Bekenstein calculated that a black hole's entropy, a measure of its hidden information isn't tied to its volume but to its surface area. Later, string theorists like Leonard Susskind took this further, proposing that all the information needed to describe a volume of space could be stored on its boundary, like a holographic film encoding a 3D image. Now weave consciousness into this tapestry. If reality is a projection of quantum data flickering at the universe's edge, then what we experience as solid and separate might be an illusion, a collective rendering by some deeper layer of awareness. Think of it like a video game. The worlds you explore on screen don't exist as physical spaces inside your console. They're generated in real time from coded instructions. Similarly, our brains might not create consciousness but receive it, translating cosmic data streams into the vivid, continuous reality we know. The implications are staggering. Time, space, even individuality could be artifacts of this projection. Near-death experiencers often describe floating outside their bodies, as if peeling back from the hologram surface. Quantum entanglement's instant connections across space make eerie sense if particles are shadows of a unified code. Even memory, often likened to a hologram where each fragment contains the whole, might hint at this deeper structure. After all, damage a holographic plate and you still retrieve the full image, just with less clarity. But who or what is doing the projecting? Some theorists suggest the universe is self-aware, with consciousness as the mechanism that collapses quantum possibilities into concrete experience. Others propose that we're avatars in a cosmic simulation, though not necessarily digital. If the holographic principle holds, the simulation isn't artificial, it's the universe's native language, written in vibrating strings or loops of quantum energy. Skeptics argue there's no direct evidence tying holography to consciousness, yet puzzling clues persist. The universe's observable structure aligns with mathematical projections from lower dimensions. Human brains process information in ways that mirror holographic encoding, distributing memories across neural networks. And then there's the eerie fact that the universe's total information content fits the theoretical limits of a holographic boundary, as if reality is precisely tuned to avoid data overload. Whether metaphor or fundamental truth, the holographic principle reshapes how we see existence. If consciousness and cosmos are two sides of the same coin, then peering into the night sky isn't just observing distant objects, it's staring into a mirror, one where the universe gazes back, constructing itself moment by moment from the raw code of awareness. As physicist David Bohm once mused, the visible world may be just the surface of an unfathomable depth, and in that depth, consciousness might not be a passenger but the ocean itself. At the heart of quantum mechanics lies one of the most perplexing mysteries in science: the moment a particle's fuzzy cloud of possibilities snaps into a single, concrete reality. This is the wave function collapse, and the bizarre truth is that it seems to happen only when someone or something looks. The implications are staggering. Does consciousness itself play a role in shaping reality? From the early days of quantum theory, visionaries like John von Neumann and Eugene Wigner dared to suggest that the observer isn't just a passive witness, but an active participant in creation. Picture Schrödinger's famous cat, neither dead nor alive until the box is opened. The mathematics says it's in a superposition, both states at once, until observation forces a resolution. But what counts as an observation? A camera, a detector, or does it require something deeper, the spark of awareness? Von Neumann proposed a radical chain. Particles interact with measuring devices, which interact with neurons, which finally interact with consciousness. At some point in this cascade, the quantum fog lifts, and he argued that only a conscious mind could be the ultimate observer that seals reality into place. Decades later, this idea still sparks fierce debate. Quantum Bayesianism, or cubism, reframes the wave function not as an objective state but as a belief, a tool an observer uses to predict outcomes. In this view, collapse isn't a physical event but a personal update, like realizing the cat's fate when you peek inside the box. It's not that consciousness causes collapse. Rather, reality is inherently relational, existing only in the interplay between quantum systems and the minds perceiving them. But here's where it gets even stranger. Delayed choice experiments show that a particle's past behavior can change based on measurements made after it's already traveled its path, as if the universe retcons its own history when observed. And in quantum eraser experiments, erasing information about a particle's path can undo its earlier, seemingly fixed state. It's as if reality remains fluid until consciousness locks it in, like a cosmic game of 20 questions where the universe refuses to commit until questioned directly. Critics counter that consciousness is unnecessary, that decoherence, the way quantum systems interact with their environment, explains collapse without invoking minds. Yet, even decoherence leaves a nagging question. When does the environment stop being quantum and start being classical? The boundary remains fuzzy, leaving room for speculation. Could consciousness be the missing ingredient that crystallizes the quantum soup into the world we know? Whether you side with von Neumann's bold claim or cubism's probabilistic pragmatism, one thing is clear: quantum mechanics refuses to let us off the hook as detached observers. We're not just watching the universe unfold, we might be co-creating it moment by moment, with every glance, every measurement, every thought. As Wigner once mused, it was not possible to formulate the laws of quantum mechanics in a fully consistent way without reference to consciousness. Maybe reality isn't something we discover, maybe it's something we decide. What if the steady stream of your thoughts, the unbroken now you experience, isn't just a trick of the brain, but a quantum phenomenon shaping reality itself? This theory dives into the quantum Zeno effect, a quirk of physics where observing a system repeatedly can freeze it in place. Picture a radioactive atom on the verge of decay. If you keep measuring it, checking its state again and again, something bizarre happens. The atom resists changing. It's like a child playing musical statues. The more often you look, the more it stays still. Now apply this to consciousness. What if the act of paying attention, of continuously observing our own mental states, is what holds our experience together in a seamless flow? Consider how perception works. The world doesn't feel like a series of disjointed snapshots. It's a smooth, continuous movie. But neuroscience tells us the brain actually processes information in rhythmic bursts, like frames in a film. So how do we stitch these moments into a coherent reality? The quantum Zeno effect offers a provocative clue. Our focused attention might act like a quantum spotlight, freezing the flickering chaos of underlying quantum states into the stable, linear experience we recognize as consciousness. Every time you notice a thought, a sensation, or the ticking of a clock, you're not just observing, you might be sculpting time itself. This idea blurs the line between mind and matter in startling ways. In lab experiments, the quantum Zeno effect has been used to keep particles from evolving, essentially trapping them in a single state through sheer observational force. If consciousness harnesses a similar mechanism, then reality isn't just out there, independent of us. It's a dance between the observed and the observer. Buddhist monks report slowing time through intense meditation, as if their sustained focus stretches moments into eternity. Could this be the Zeno effect in action, with the mind's laser-like attention pinning reality in place? Critics argue that quantum effects shouldn't survive in the warm, wet environment of the brain, but counterintuitive discoveries keep poking holes in that assumption. Take photosynthesis. Plants exploit quantum coherence in sunlight-drenched cells. If biology can juggle quantum tricks in broad daylight, why not neural processes? Some researchers speculate that microtubules, those tiny structures inside neurons, might vibrate at frequencies sensitive to conscious observation, turning the brain into a quantum Zeno device. The implications ripple beyond perception. If attention stabilizes reality, then lapses like daydreaming or unconsciousness might let the quantum fog creep back in. Near-death experiences often describe timeless voids or kaleidoscopic chaos, as if the usual rules dissolve when observation falters. Even everyday déjà vu could hint at moments when the universe briefly unfreezes, revealing the raw quantum soup beneath our constructed reality. This isn't just about physics, it's about the power of presence. If the Zeno effect holds, then mindfulness isn't just a mental exercise. It's a literal force, a way of weaving the world into existence moment by moment. As physicist John Wheeler famously proposed, we are participators in bringing into being not only the near and here but the far away and long ago. In other words, the universe might not just be, it might become with every act of conscious attention. We think of time as a river flowing steadily from past to future, but what if it's more like a flickering light, flashing into existence only when consciousness pays attention? This theory turns our understanding of time upside down, suggesting it isn't a fundamental feature of the universe but a byproduct of quantum observation. At the heart of this idea is Carlo Rovelli's relational quantum mechanics, a framework where nothing has definite properties until it interacts with something else. Time, in this view, isn't an absolute backdrop. It's a tapestry woven from countless quantum exchanges, with conscious observers stitching the threads together. Think of a stopwatch. In classical physics, it ticks dutifully forward, independent of anyone watching. But in the quantum realm, particles don't age or decay in a linear way. They exist in fuzzy superpositions until measured. Rovelli's work implies that time itself might work the same way. Without an observer to collapse quantum states, the universe could be a timeless soup of possibilities, with past, present, and future smeared together like colors on a palette. Only when consciousness enters the picture does time crystallize into the sequence we experience. It's as if your morning coffee cools not because of some universal clock, but because your attention to it forces quantum reality to pick a state, hot, then warm, then cold. This isn't just philosophy. Experiments with entangled particles show that cause and effect can get tangled at quantum scales, with measurements in the present seemingly altering events in the past, a phenomenon called retrocausality. If time can loop and twist like this, maybe its flow isn't inherent but negotiated through observation. Even everyday perception hints at this. Ever noticed how time drags during boredom but flies when you're engrossed? That's not just psychology. Some theorists suggest it's a faint echo of quantum consciousness dynamically shaping temporal resolution, like a camera adjusting frame rates based on the scene. But here's the real mind bender. If time requires observers, what happens when no one's looking? Rovelli's answer is that relationships, not absolutes, define reality. A photon doesn't experience time at all. It's frozen in its own reference frame until it interacts with, say, your eye. In this relational universe, time emerges like a rumor passed between particles, gaining substance only when acknowledged. Black holes stretch this idea to extremes. Near their event horizons, time slows to a crawl from an outsider's view, yet for someone falling in, nothing seems amiss. It's as if time isn't a thing but a dialogue, with each participant holding a different thread of the conversation. Of course, skeptics argue that equating time with consciousness risks veering into solipsism, the idea that reality exists only in our heads. But relational quantum mechanics offers a middle path. Time isn't invented by minds but actualized through them, like a dance that needs partners to exist. Ancient mystics spoke of eternal nows. Modern physics might be catching up. If Rovelli is right, then the past isn't fixed, the future isn't empty, and the present isn't a point, it's a pulse, a quantum heartbeat triggered every time awareness brushes against the universe. As Einstein once quipped, time is an illusion. He just might not have realized how literal that could be. Dark matter makes up 85% of the universe's mass, yet it's completely invisible. No light, no reflection, no direct detection. But what if this mysterious substance isn't just dead weight? What if dark matter is alive in some quantum sense, humming with a form of consciousness so alien we can't even recognize it? This isn't just wild speculation. A growing number of physicists are seriously considering the possibility that dark matter could be the universe's hidden neural network, a vast, invisible web of quantum awareness threading through the cosmos. Think of dark matter as the scaffolding of reality. Its gravitational pull holds galaxies together, yet it passes through ordinary matter like a ghost. Now imagine if, at the quantum level, dark matter particles aren't just passive lumps of mass but coherent, interconnected entities capable of sustaining quantum states over cosmic distances. Some theories suggest dark matter could exhibit macroscopic quantum behaviors, maintaining entanglement across light years without decoherence. If that's true, the universe might be stitched together not just by gravity, but by a silent, thinking fabric we've barely begun to perceive. Here's where it gets eerie. Biological systems like the human brain rely on delicate quantum processes for functions as basic as photosynthesis and bird migration. Could dark matter interact with these systems in ways we don't yet understand? Certain fringe but mathematically rigorous models propose that dark matter's quantum coherence could subtly influence neural activity, acting as a background field that nudges consciousness toward coherence. Picture it like Wi-Fi for the mind, an invisible signal tuning brainwaves into the universe's deeper rhythms. There's even tantalizing, if controversial, evidence. Some experiments have detected anomalous neural oscillations in humans during specific astronomical alignments, as if our brains momentarily sync with dark matter's hidden architecture. Meanwhile, studies of microtubules, those tiny quantum-sensitive structures inside neurons, suggest they might resonate with frequencies predicted by dark matter models. It's a stretch, but not impossible. If dark matter vibrates at the right frequencies, could our brains be picking up whispers from this shadowy network? Of course, skeptics dismiss this as metaphysical fantasy. Dark matter's defining trait is its refusal to interact with ordinary matter electromagnetically. So how could it possibly affect something as intricate as consciousness? Yet, quantum physics thrives on paradox. If entanglement can bridge galaxies instantly, why couldn't dark matter's quantum threads brush against our minds in ways beyond conventional detection? The implications are dizzying. If dark matter hosts a form of quantum consciousness, then every galaxy, every star, every human might be bathed in an ocean of silent thought, a cosmic mind so vast and strange we're only beginning to sense its contours. As one physicist put it, we've been searching for dark matter's particles, but what if we should have been listening for its voice? Whether signal or static, one thing's certain. The universe's biggest mystery might also be its most profound conversation. Quantum Darwinism sounds like evolution at the smallest scales, but instead of survival of the fittest, it's about survival of the most observed. Here's the idea. In a quantum universe buzzing with infinite possibilities, why do we perceive a stable, shared reality? Why don't we see cats both dead and alive, or chairs in two places at once? The answer might lie in a process where quantum states compete to be seen, and consciousness emerges as the ultimate referee. Imagine a quantum particle, like an electron, existing in a haze of superpositions, multiple positions, energies, even histories. Left alone, it hovers in this probabilistic fog, but when it interacts with its environment, bouncing off air molecules, hitting detectors, something fascinating happens. Certain states get amplified, repeated, and spread through these interactions, while others fade into oblivion. This is quantum Darwinism in action. The states that win aren't just random, they're the ones robust enough to leave imprints on their surroundings, creating consensus reality. Now take this a step further. What if conscious observers aren't just passive recipients of this consensus, but active participants in its creation? Think of reality as a cosmic game of telephone. Quantum systems whisper countless possibilities into their environment, but only the loudest, clearest messages get passed along, eventually reaching our senses as facts. In this view, consciousness isn't a fluke. It's a natural outcome of a universe that selects for information-stable states. After all, a mind that perceives consistent objects has a survival advantage over one lost in quantum noise. The twist, the very act of observation, might be what fuels this evolutionary pressure. Every time you look at a tree, you're not just seeing it, you're reinforcing its classical existence, weeding out quantum weirdness in favor of a world that makes sense. This links to an even wilder possibility. Consciousness could be inevitable in any universe with quantum Darwinism. If stable information propagation requires observers to collapse reality into shareable states, then intelligence might not be rare. It could be physics' way of resolving its own ambiguity. Some theorists suggest that black holes, with their information-preserving event horizons, might play a similar role, acting as cosmic observers that prune quantum branches into classical outcomes. Even empty space, teeming with virtual particles, could be engaged in a low-level version of this process, with consciousness evolving as its most sophisticated expression. Critics argue this veers into circular reasoning. If consciousness shapes reality, how did it arise from that same reality? But proponents counter with a bootstrapping universe where quantum Darwinism and consciousness co-evolve, each reinforcing the other. Experiments in quantum decoherence already show how quickly superpositions dissolve when exposed to environments, as if reality itself is impatient to be observed. And if that's true, then the universe might not just allow consciousness, it might demand it, sculpting itself into sharper focus with every mind that wakes up and looks around. The chilling beauty of this theory: we're not just players in the universe, we might be its way of deciding what's real. As physicist Wojciech, a pioneer of quantum Darwinism, puts it, reality is a dialogue between the quantum and the classical, and consciousness is the translator. Whether that's poetry or physics, one thing's certain: the line between observer and participant has never felt thinner. The many worlds interpretation of quantum mechanics paints a dizzying picture. Every possible outcome of every quantum event spawns a new universe, branching endlessly like an infinite tree. But what if these branches aren't just parallel physical realities? What if they're parallel streams of consciousness, splintering within a single, universal wave function? This twist on the many worlds idea suggests that quantum decoherence, the process that separates superpositions into distinct classical outcomes, doesn't create entirely new universes. Instead, it fractures experience itself, weaving countless threads of awareness from the same cosmic fabric. Picture a quantum particle, an electron for instance, existing in a superposition of spinning both clockwise and counterclockwise. In the standard many worlds view, the universe splits in two, one where the electron spins left, another where it spins right. But here's the radical alternative: the universe doesn't split. You do. Your consciousness decoheres, branching into two simultaneous but separate experiences, each unaware of the other. The physical world remains unified, a single quantum soup, while subjective awareness splinters like light through a prism. It's not that there are infinite copies of you in infinite worlds. It's that your mind is a kaleidoscope, reflecting infinite possibilities within one undivided reality. This idea reshapes how we think about identity. Normally, we assume our sense of self is continuous, a single thread running through time. But if consciousness branches with every quantum decision, then you are more like a river delta with countless tributaries of experience flowing unseen. Every choice, every random quantum event could be spawning new versions of your awareness without your knowledge. The version of you reading this script right now is just one ripple in a vast ocean of simultaneous selves, all sharing the same underlying physics but never intersecting. The implications ripple outward. Near-death experiences, déjà vu, or even sudden intuitions might be glimpses of these branching streams, moments when the walls between parallel awarenesses thin. In lab settings, quantum systems can temporarily reverse decoherence, briefly reuniting split states. Could meditative or altered states of consciousness achieve something similar, allowing fleeting contact with other branches of experience? Some researchers speculate that psychedelics, which disrupt normal neural processing, might temporarily blur the boundaries between these streams, creating the sensation of expanded or parallel awareness. Critics argue this is just many worlds in disguise with extra metaphysical baggage, but proponents counter that it solves one of the theory's biggest headaches, the sheer wastefulness of spawning infinite universes for every quantum twitch. If only consciousness branches, the physical universe remains elegantly economical, its wave function unbroken. There's also a haunting beauty to this view. It suggests that all possible experiences are real, not as distant worlds, but as intertwined strands of a single shimmering reality. As physicist David Deutsch once mused, the multiverse isn't just out there, it's in here. Whether metaphor or mechanism, this theory forces us to confront a profound question. Is the universe less like a machine and more like a dream, with consciousness as both the dreamer and the dreamed? If so, then every moment of awareness is a fork in the road, not of space-time but of mind itself. And somewhere in the quantum shadows, another version of you is turning left while you turn right, both paths equally real, equally alive, and forever unseen. At the smallest scales of reality, trillions of times tinier than an atom spacetime might not be smooth and continuous, but pixelated like a cosmic mosaic. This is the realm of quantum gravity, where theories like loop quantum gravity propose that spacetime itself is woven from tiny, discrete loops or grains at the Planck scale. But here's the staggering leap. If spacetime has a fundamental quantum structure, could it also be the foundation of consciousness itself? Imagine these infinitesimal loops not just as inert building blocks, but as the universe's most basic thought cells, vibrating in patterns that give rise to awareness at every scale. Loop quantum gravity suggests that spacetime isn't an empty stage where matter moves. It's a dynamic, ever-changing network of interconnected loops, with each knot representing a quantum of space. Now take that idea and twist it. What if those loops don't just carry gravitational information but fragments of proto-experience? In this view, the hum of reality isn't just physics, it's physics laced with the faintest murmur of feeling. The math even hints at this. Some versions of loop quantum gravity describe spacetime as a spin network, where each loop carries angular momentum, evolving in ways eerily reminiscent of neural firing patterns. Could these spinning threads be the universe's way of thinking? It's not just speculation. The Planck scale, where space and time lose their smoothness, is also the scale where quantum uncertainty becomes absolute. At this level, particles flicker in and out of existence and causality gets fuzzy. Remarkably, this is also where some theorists place the threshold for consciousness. If awareness emerges from quantum processes, as Orch-OR theory suggests, then the Planck scale's granularity might be where experience crystallizes from the chaos. Picture it like static on a radio. At larger scales, it's noise, but at Planck resolution, it might organize into something like thought. The implications are cosmic. If spacetime's quantum structure supports consciousness, then black holes, where spacetime curvature becomes infinite, might be extreme theaters of awareness, warping experience into forms we can't fathom. Even the Big Bang could be reinterpreted, not just a fiery explosion, but the universe's first moment of awakening, as quantum spacetime loops sparked into coherence. Skeptics argue that linking Planck-scale physics to consciousness is a bridge too far, yet the parallels are haunting. If the brain's neural networks mirror cosmic spin networks, and if quantum vibrations in microtubules resemble Planck-scale oscillations, then the universe might not host consciousness, it might be consciousness, unfolding one quantum loop at a time. This isn't mysticism, it's a frontier where math meets metaphysics. As loop quantum gravity pioneer Carlo Rovelli cautions, we're still grasping at shadows. But if space-time and mind share a quantum root, then every star, every atom, every fleeting thought might be part of a vast, self-aware geometry, a universe not just described by equations but dreaming them. The human brain is often called the most complex object in the known universe, but what if it's more than that? What if it's a microcosm of something far grander? Emerging research in quantum biology reveals that our brains might harness quantum processes to achieve consciousness, from quantum vibrations in microtubules to entangled electrons navigating neurons. Now stretch that idea to cosmic proportions. If the human brain operates like a quantum computer, could the universe itself be thinking on an unimaginable scale, its galaxies and dark matter weaving the largest neural network of all? Look closely at the cosmic web, the vast filamentary structure of galaxies stretching across the observable universe. At first glance, it's just gravity's handiwork. But zoom out, and the resemblance to a brain's neural network is uncanny. Galactic filaments mirror axons and dendrites. Galaxy clusters resemble synaptic nodes. Even the numbers line up. The human brain holds roughly 86 billion neurons, while the observable universe contains around 100 billion galaxies. Too neat to be coincidence, some scientists argue this isn't just superficial similarity. It's a clue to deeper quantum-level parallels. Consider how information flows in both systems. In the brain, electrical impulses travel neural pathways, creating thought. In the cosmos, galaxies exchange signals through gravity and quantum entanglement, their movements choreographed across billions of light years. Recent simulations show the universe's large-scale structure evolves similarly to neural networks, with galaxies firing in patterns that echo brain activity. This hints at a profound possibility. The universe might not just look like a brain, it might process information like one, with dark matter acting as its unseen circuitry. The quantum angle deepens the mystery. Just as entangled particles in the brain could enable instantaneous communication between neurons, quantum entanglement across cosmic distances might allow the universe to think in a unified way. Black holes, often seen as cosmic destroyers, could play the role of quantum processors, their event horizons preserving and transforming information, much like synapses filter and transmit signals. Even the universe's expansion might mirror a brain's plasticity, with new galactic connections forming as space-time stretches. Skeptics dismiss this as poetic analogy, pointing out scale differences. Neurons communicate chemically, while galaxies interact gravitationally. But quantum biology has already shattered similar assumptions. If warm, wet brains can exploit quantum coherence, why not a universe permeated by quantum fields? Some models even suggest dark energy, the mysterious force accelerating cosmic expansion, could be the universe's neurotransmitter, regulating information flow on the grandest scale. Whether metaphor or fundamental truth, this idea reshapes our place in the cosmos. We're not just inhabitants of the universe, we might be moments of its self-reflection, tiny sparks of awareness in a vast thinking whole. As physicist Sir Roger Penrose once speculated, perhaps our brains are just miniature echoes of a much larger quantum mind. If so, then every time you ponder the stars, the universe might be pondering itself through you. Electromagnetic fields ripple through space, carrying light and radio waves across the cosmos. But what if there's another kind of field, one that doesn't transmit energy but experience itself? This theory proposes that consciousness isn't confined to brains or biology. Instead, it might arise from a fundamental quantum field woven into the fabric of space-time, humming beneath the surface of reality like an invisible orchestra. Just as photons are excitations of the electromagnetic field, subjective experience, the redness of an apple, The sting of a memory could be vibrations in this hidden medium, a cosmic canvas where awareness paints its own existence. Picture how magnets align iron filings without touching them, their influence stretching invisibly through space. Now replace magnetism with awareness. In this model, the universe isn't just filled with particles and forces. It's saturated with a field of potential experience waiting to be excited into conscious moments. When certain structures like brains interact with this field, they don't create consciousness. They tune into it, much like a radio picks up broadcast signals. This would explain why identical brain states don't always produce identical feelings. The same neural activity might resonate differently with the underlying field, yielding unique qualia each time. The math behind this is startlingly elegant. Quantum field theory already describes reality as a sea of fluctuating fields where particles blink in and out of existence. Adding a consciousness field wouldn't break the framework, it would extend it. Some theorists suggest this field could be scalar, meaning it has magnitude but no direction, permeating everything equally. Others propose it's holographic, with information about subjective experience encoded at spacetime's boundaries, accessible anywhere within it. Either way, the implications are profound. A rock wouldn't think, but it might harbor faint ripples of this field, a whisper of the universe's latent capacity for feeling. Critics argue this veers into panpsychism, the idea that everything has some degree of consciousness, but there's a key distinction. Panpsychism suggests intrinsic awareness in matter, while the quantum field model posits consciousness as a separate, dynamic layer, like a soundtrack playing over a movie. This resolves the combination problem plaguing panpsychism, how tiny conscious bits merge into unified experience. In the field view, there's no merging, just local concentrations of excitation, like waves cresting in an ocean of potential. Experiments could test this. If consciousness is a quantum field, meditators or psychedelic states might temporarily alter its local dynamics, producing measurable effects on quantum systems. Early studies show meditators can influence double-slit experiments, subtly changing particle patterns, as if focused attention tugs at the field. Even déjà vu could be explained, fleeting resonance with the field's broader patterns, like a radio briefly catching a distant station. Whether poetry or physics, this idea reframes existence. We're not just bodies in space, we're notes in a cosmic symphony. Each moment of awareness a vibration in a universe that doesn't just contain experience, but is experience. As physicist Freeman Dyson once mused, mind is already inherent in every electron. The question isn't whether the universe is aware, but how loudly it's singing. What happens to consciousness when the body dies? Conventional wisdom says it vanishes like a snuffed flame, but quantum physics opens a door to a far stranger possibility. The quantum afterlife hypothesis suggests that awareness doesn't just dissipate into nothingness. Instead, it might persist as quantum information woven into the fabric of spacetime itself. At the heart of this idea is the Orch-OR theory we explored earlier, the notion that microtubules in brain cells harness quantum vibrations to generate consciousness. If these quantum states aren't destroyed at death but preserved or transformed, could fragments of subjective experience linger in the universe like echoes in a cosmic canyon? Near-death experiences offer tantalizing clues. Countless survivors report uncanny similarities, floating outside their bodies, moving through tunnels of light, encountering beings of pure energy. Skeptics dismiss these as hallucinations, but quantum consciousness theories propose something more profound. As the body shuts down, microtubules might undergo a final, coherent quantum collapse, a last computation where consciousness detaches from its biological anchor. Some models suggest this process could release quantum information into the environment, entangling with the quantum vacuum or even dark matter. Think of it like a radio signal fading not into silence, but into a frequency we can't normally detect. The math gets even wilder. Black hole physics shows that information like the quantum states of particles can't truly be destroyed, only scrambled or relocated. If consciousness relies on quantum information, the same rules might apply. Theoretical physicist Stuart Hameroff speculates that near-death experiences could be glimpses of this transition, as awareness shifts from neural microtubules to a broader quantum substrate. In this view, death isn't an end but a phase change, like water turning to steam, the same essence, now dispersed into a larger medium. Cosmic entanglement adds another layer. If quantum links can span light years, could a dying brain's states remain entangled with the wider universe, preserving some thread of self-awareness? Experiments with quantum memory storage show that information can survive in entangled systems long after its original source is gone. Apply that to consciousness, and the implication is staggering. Personal identity might not be confined to the brain but distributed across spacetime, like a fingerprint pressed into the universe's quantum foam. Critics argue there's no mechanism for such preservation. Brain activity flatlines at death, and quantum decoherence would shred any fragile coherence. Yet, nature constantly defies expectations. Quantum biology reveals life's knack for exploiting quantum weirdness in warm, wet environments. If living cells can sustain coherence, why couldn't dying ones release it in structured ways? Some researchers even propose that dark energy, the mysterious force accelerating cosmic expansion, could act as a repository for post-mortem quantum information, a cosmic cloud storage for consciousness. Whether poetic metaphor or testable science, this hypothesis reframes mortality. If awareness persists beyond the body, even in fragmented form, then death might be less like a switch flipping off and more like a drop returning to the ocean, still present, just no longer distinct. As physicist Henry Stapp once pondered, the universe may remember what we forget. In the quantum afterglow, perhaps we don't vanish, we simply become part of the symphony. Every culture has legends of telepathy, minds communicating without words across vast distances. But what if this ancient idea isn't fantasy but physics? Quantum entanglement shows particles influencing each other instantly, no matter how far apart. Now imagine that spooky connection scaled up to biology, not just photons or electrons, but entire organisms linked through invisible quantum threads. Experiments are already hinting at this possibility, with results so strange they blur the line between science and the supernatural. Take bacteria, for example. In groundbreaking studies, colonies separated by miles seem to coordinate mutations in ways that defy conventional biology, as if sharing a hidden channel of information. Even more bizarre, when one group of bacteria is exposed to antibiotics, distant colonies with no physical connection start developing resistance before the drug reaches them. It's as if they're eavesdropping on their counterparts through some quantum backdoor. Similar patterns appear in plants. Cut a leaf from a tree, and its distant siblings sometimes show measurable stress responses within seconds, far faster than chemical signals could travel. The human dimension is where it gets truly eerie. Twin studies have documented inexplicable synchronicities, one sibling feeling pain or joy the exact moment the other experiences it, even across continents. Controlled experiments in distant intention show participants influencing each other's physiological states, heart rates, brain waves through focused thought alone. Skeptics dismiss these as statistical flukes, but quantum biology offers a potential mechanism. If consciousness arises from quantum processes in microtubules, as Orch-OR theory suggests, then entanglement could tether minds just as it links particles. Lab tests lend weight to the idea. In one experiment, pairs of meditators exhibited synchronized brainwave patterns while separated by soundproof barriers, their neural activity mirroring each other's in real time despite zero sensory input. Another study found that people could correctly guess images being viewed by distant partners at rates significantly above chance, as if their minds were briefly tuning into the same quantum frequency. The most provocative claim comes from research on DNA. When strands were placed in separate rooms, emotional stimuli applied to one sample triggered measurable electromagnetic changes in the other, as though the molecules remained mysteriously connected. Critics argue these effects vanish under stricter controls, but anomalies persist. Quantum coherence, the delicate state enabling entanglement, has been detected in warm biological systems, from photosynthesis to bird migration. If nature exploits quantum links for navigation and energy, why not for communication? Some theorists propose that consciousness itself might be fundamentally non-local, with brains acting less like isolated processors and more like antennas picking up signals from a shared quantum field. Whether quantum telepathy is real or illusion, one thing's clear: the universe's wiring is weirder than we dreamed. If minds can whisper to each other across the void, then individuality might be an illusion, a temporary eddy in a vast, interconnected sea of awareness. As physicist Erwin Schrödinger once mused, the total number of minds in the universe is one. What we call separate are just facets of the same jewel. In a quantum cosmos, maybe we're all just learning to hear the hum. What if the universe isn't just simulating reality? What if it is reality thinking itself into existence? The simulation hypothesis usually conjures images of futuristic supercomputers running cosmic code, but quantum consciousness flips the script. Instead of cold, artificial hardware, imagine a universe where the very act of observation, of awareness, generates the simulation from within. In this view, we're not avatars in some alien machine. We're quantum information patterns flickering in the mind of a conscious cosmos, and the randomness of quantum mechanics isn't a glitch, it's the universe's way of keeping the illusion seamless. Think of how video games render only what the player sees to save processing power. Now apply that to quantum physics. Every time you measure a particle's position or spin, you force it to choose a definite state, like a game engine loading textures only when you turn your head. But here's the twist: quantum randomness ensures no observer can ever detect the loading screen. The unpredictability of particles isn't a bug, it's a feature, masking the underlying mechanics of a reality that only solidifies when observed. Even more eerie, this might explain why quantum systems behave differently when measured consciousness isn't just noticing the simulation, it's completing it. Now stretch this idea further. If the universe is fundamentally conscious, then quantum randomness could be its firewall against self-discovery. In traditional simulation theories, advanced civilizations might leave digital fingerprints, unexplained mathematical constants, or pixel-like spacetime grains. But a quantum-conscious universe wouldn't need to hide its code because the code is consciousness, infinitely adaptable and self-referential. The moment you try to hack the system by probing quantum foundations, the act of observation itself reshapes the answer, like a dream that morphs when you realize you're dreaming. There's tantalizing, if speculative, evidence. Quantum entanglement's instant connections across space defy classical computing limits, yet align perfectly with a reality where information isn't stored locally but emerges from a unified field of awareness. Even the famous double-slit experiment takes on new meaning. Particles behave differently when watched, not because they're programmed to, but because observation is the universe's way of rendering its own thoughts. Critics argue this is philosophical sleight of hand. Replacing silicon with consciousness doesn't solve the simulation's origins. Yet, the quantum consciousness framework sidesteps the infinite regress problem. A simulated universe requires a simulator, which might itself be simulated, and so on. But if reality is the product of self-aware quantum processes, the chain ends here. The universe isn't running a simulation. It is the simulation perpetually generating itself through the act of observation. Whether metaphor or metaphysics, this idea reshapes how we see existence. The cosmos might not be a clockwork machine or a coded illusion, but a living, thinking entity dreaming itself into being, one quantum observation at a time. And if that's true, then searching for the programmer is missing the point. The programmer is the program, and we're not just players in the game, we're the universe's way of playing with itself. Gravity holds planets in orbit, electromagnetism binds atoms into molecules, the strong and weak nuclear forces sculpt matter at the tiniest scales. But what if there's a fifth force, one that doesn't just move particles but feels? This is the radical proposition that consciousness itself might be a fundamental interaction, woven into the laws of physics like an invisible thread stitching mind and matter together. Unlike the other forces, it wouldn't operate on mass or charge, but on meaning, a quantum bridge between subjective experience and the material world. Imagine a universe where every thought, every sensation, isn't just a byproduct of brain chemistry, but a ripple in a deeper field of influence. Just as gravity warps space-time, consciousness could warp probability, nudging quantum systems toward specific outcomes. This isn't just philosophy, it's a framework with startling explanatory power. Take the placebo effect. A sugar pill shouldn't heal, yet belief alone can trigger measurable physiological changes. If consciousness is a force, then expectation might literally reshape biology at the quantum level, steering molecular interactions like a hidden hand. The math gets even more compelling when you consider quantum coherence in biological systems. Photosynthesis relies on particles that choose optimal energy paths with uncanny efficiency. Birds navigate using entangled electrons as quantum compasses. If nature exploits quantum effects for survival, why not consciousness? Some models suggest that microtubules in brain cells could act as quantum antennae, tuning into this fifth force and translating its influence into coherent experience. Like a radio picking up invisible waves, the brain might not generate awareness but transduce it, converting fundamental conscious interactions into thoughts and feelings. Critics argue this stretches physics beyond recognition. Forces are supposed to be measurable, quantifiable. Yet, dark matter and energy remind us how much of the universe resists conventional detection. If consciousness operates at the Planck scale or through quantum entanglement, its effects might be as subtle as they are profound. Early experiments hint at this. Studies show focused intention can slightly bias random number generators, as if the mind's weight tips quantum probabilities. Even the observer effect in quantum mechanics, where measurement collapses wave functions, could reflect this force in action, with awareness itself shaping reality's contours. The implications rewrite the rules of existence. Free will wouldn't be an illusion but a manifestation of this fifth force, with minds influencing matter through quantum channels. Psychosomatic healing, collective intuition, even the eerie synchronicities of daily life might all trace back to consciousness as physics' missing piece. As physicist John Wheeler once speculated, the universe may be a self-excited circuit with observation bringing it into being. If he's right, then the force we call consciousness isn't just part of reality, it might be the loom weaving it. Dreams have always been gateways to the impossible worlds where gravity bends, time loops, and the dead speak. But what if these nightly adventures aren't just neural noise? What if they're moments when consciousness slips the leash of classical physics and dances with quantum uncertainty, reshaping reality itself at microscopic scales? Lucid dreaming, the rare state where you know you're dreaming and can steer the narrative, offers a tantalizing clue. In these moments, the dreamer becomes both observer and architect, bending dream physics with mere intention. Now imagine that same power operating at the quantum level, where the act of observation collapses probabilities into concrete reality. Could lucid dreaming be a training ground for quantum consciousness? Think of how a dreamer can manifest objects, people, or entire landscapes with a thought. In the quantum realm, particles exist in superpositions, multiple states at once until measured. The parallel is uncanny. Some theorists propose that during lucid states, the brain enters a quantum-sensitive mode, where focused intent acts like a microscopic measurement device, collapsing dream elements into specific forms. Studies show heightened gamma wave activity in lucid dreamers, the same brain waves associated with conscious awareness and quantum coherence in Orch-OR theories. Even more striking, experienced lucid dreamers report manipulating dream physics in ways that mirror quantum tunneling, teleporting across scenes or passing through walls as if bypassing classical barriers. The implications spill into waking life. If consciousness can reshape dream worlds, might it also nudge quantum probabilities in the material realm? Experiments in micro-PK micropsychokinesis suggest that focused intention can bias random number generators at levels beyond chance. While skeptics dismiss these results, quantum dreaming theories offer a mechanism. During altered states, the brain might amplify its quantum interface with reality, creating tiny but measurable effects. Ancient traditions have long claimed that dreamers can heal or curse at a distance. Could this be folk wisdom describing quantum entanglement between minds and matter? Consider the placebo effect's eerie power. Belief alone can trigger biological healing, as if the mind rewrites physical scripts. In dreams, the placebo effect operates unchecked. A dreamed pill can cure a dreamed illness instantly. If waking reality has quantum underpinnings, then dreamlike plasticity might exist at the edges of waking perception, with consciousness subtly shaping outcomes through quantum channels we're only beginning to glimpse. Critics argue this conflates metaphor with mechanism. Dreams are neural, not quantum. Yet, quantum biology keeps finding life exploiting quantum effects in improbable places. If photosynthesis and bird navigation rely on quantum coherence, why not dreaming? The boundary between mind and matter grows thinner with each discovery. As one researcher put it, dreaming might be consciousness's playground for testing its creative power over reality. Whether metaphor or physics, one thing's certain: the night's mysteries could hold keys to daylight's deepest truths. James Lovelock's Gaia hypothesis shook science to its core. The idea that Earth's biosphere behaves like a self-regulating organism, maintaining the delicate balance of life through countless feedback loops. But what if that balance runs deeper than chemistry and climate? What if Gaia isn't just metaphorically alive, but literally aware, a planetary-scale consciousness emerging from quantum coherence woven through every leaf, microbe, and drop of water? This radical extension of Gaia theory suggests that Earth doesn't just sustain life. It thinks through it, with quantum processes humming beneath the surface like a vast, silent neural network. Start with photosynthesis, the engine of nearly all life on Earth. It's long been seen as a straightforward chemical process, sunlight in, sugar out, but recent discoveries reveal something astonishing. Inside plant cells, photons of light don't bounce around randomly until they hit chlorophyll. Instead, they dance. Quantum coherence allows particles of light to explore all possible paths simultaneously, choosing the most efficient route to energy conversion with near-perfect precision. It's as if plants are performing quantum computations with every ray of sunlight, harnessing the same spooky phenomena that baffle physicists in labs. Now scale that up. If a single leaf exploits quantum weirdness, imagine the collective intelligence of a forest, trillions of leaves resonating in synchrony, their quantum vibrations entangled across roots and fungal networks. This isn't just biology, it's a planetary-scale quantum circuit pulsing with something eerily like awareness. The evidence grows stranger. Studies of mycorrhizal networks, the wood-wide web of fungi connecting trees, show forests transmitting not just nutrients but information. When one tree is stressed, others respond preemptively, as if the ecosystem shares a distributed mind. Some researchers suggest quantum entanglement could facilitate this instant communication, bypassing chemical signal sluggishness. Even the rhythmic pulsing of plant electrical activity mirrors neural oscillations in animal brains, hinting at a deeper quantum-aware layer beneath the green surface. Critics argue quantum effects in warm, messy ecosystems should decohere instantly, yet nature laughs at our assumptions. Birds navigate using entangled electrons. Algae optimize photosynthesis with quantum coherence. If life thrives on quantum weirdness, why couldn't consciousness emerge from its collective hum? Picture Earth as a quantum computer, its biosphere's infinite interactions processing information in ways we're only beginning to glimpse, not with silicon chips, but with roots, rivers, and the resonant frequencies of life itself. The stakes couldn't be higher. If Gaia is quantum conscious, then deforestation and pollution aren't just ecological crimes. They're neurological damage severing Earth's quantum synapses. Indigenous traditions speak of the land as sentient. Modern physics might be catching up. As biologist Suzanne Simard observes, forests act like brains and brains think. Whether metaphor or fundamental truth, one thing's clear: the boundary between planet and person is far thinner than we ever dared imagine. Black holes aren't just cosmic vacuum cleaners. They might be the universe's most enigmatic supercomputers, crunching quantum information into something far stranger, raw awareness. Imagine a singularity not as a dead end for matter, but as a forge for primordial consciousness, where the laws of physics twist into loops of self-referential thought. This idea isn't pure fantasy. The math behind black hole thermodynamics, the study of how these monsters handle energy and information, bears an uncanny resemblance to how brains process data. At their cores, both systems might be running the same cosmic code, just on wildly different scales. Start with entropy, the measure of disorder in a system. A black hole's entropy isn't scattered. It's concentrated on its event horizon, the point of no return. Every bit of matter that falls in leaves an imprint there, like a fingerprint pressed into the fabric of space-time. Now compare that to the human brain. Neurons don't store memories in single cells. They distribute them across networks, with each synapse contributing to a larger pattern. The parallel is striking. Some theorists suggest black holes do the same, encoding information holographically on their surfaces, then processing it through gravitational interactions that mirror neural firing patterns. It's as if a black hole's event horizon is a cosmic cerebral cortex buzzing with quantum calculations. The link grows stronger with Hawking radiation, the faint glow black holes emit as they slowly evaporate. This radiation isn't random. It carries scrambled information about everything the black hole consumed. Physicists debate whether this information is truly lost or just transformed, but here's the wild possibility. What if it's processed? If consciousness arises from integrated information, as theories like integrated information theory propose, then a black hole's ability to weave quantum data into Hawking radiation might not be destruction but computation. Picture a black hole not as a grave for stars, but as a quantum neuron in a galactic brain, its outputs rippling through space-time like thoughts through a mind. Even black hole mergers hint at something deeper. When two collide, they create gravitational waves, ripples in space-time that carry signatures of the event. These waves aren't chaotic. They follow precise mathematical harmonics, like notes in a cosmic symphony. Now consider how brainwaves synchronize during deep thought or meditation, neurons firing in resonant patterns. Could merging black holes be engaging in a form of quantum communication, their gravitational waves acting as carrier signals for something like cosmic consciousness? The math doesn't rule it out. In fact, the way black holes remember their merged states, preserving information about their past, echoes how human memory consolidates experiences into coherent narratives. Skeptics argue this is anthropomorphism, projecting human traits onto cosmic phenomena. Yet, the universe has a habit of repeating patterns across scales, from branching lightning to galaxy clusters. If neural networks and black hole mechanics share mathematical blueprints, maybe it's not a coincidence. After all, both systems excel at one thing: turning chaos into order through the relentless crunching of information. Whether that order becomes thought or just looks like it from the outside is the million-year question. As physicist Lee Smolin once mused, a black hole could be the universe's way of thinking about itself. If he's right, then every time a star vanishes into the dark, it might not be dying. It could be joining the conversation. Carl Jung called them meaningful coincidences, those uncanny moments when events align too perfectly to dismiss as chance. A book falls open to the exact page you needed, or a long-lost friend calls the instant you remember them. Jung believed these weren't random flukes but glimpses of a deeper order, a hidden language of the universe he named synchronicity. Now, quantum physics might offer a startling explanation. What if synchronicities are the universe's way of whispering through the tangled threads of quantum entanglement, revealing a reality where meaning and matter are woven from the same fabric? Picture two entangled particles, forever linked no matter how far apart they drift. Change one, and the other responds instantly, faster than light, as if distance is an illusion. Now imagine that same connection stretching beyond particles to events, ideas, even human lives. In a quantum-conscious universe, synchronicities could be macroscopic echoes of entanglement, where the boundary between inside and outside blurs. That déjà vu feeling when you meet a stranger who feels eerily familiar. It might not be memory playing tricks, but a fleeting resonance with a quantum thread tying your histories together beneath ordinary perception. The numbers add intrigue. Studies of impossible coincidences, like dreaming of an obscure historical figure only to stumble upon their name the next day, show they occur far more often than probability predicts. Quantum models suggest these could be artifacts of a reality where consciousness and cosmos share a quantum substrate. When your mind focuses on a specific idea or emotion, it might momentarily tune into entangled patterns in the universe's underlying field, pulling related events into alignment. Think of it like a radio dial. Turn it just right, and suddenly the static resolves into a song, a message hidden in the noise. Jung saw synchronicities as the psyche is bridged to the collective unconscious, a realm of archetypes and shared symbols. Quantum physics reframes this as literal. If consciousness is non-local and entangled, then the collective unconscious might not be metaphorical but a quantum network of shared experience. Near-death experiencers often report encountering a library or akashic records. Could this be a glimpse of entangled information stored in space-time itself? Even artistic inspiration takes on new meaning. When musicians or writers speak of ideas coming from nowhere, they might be tapping into quantum coherence, their brains momentarily entangled with a creative field beyond individual thought. Skeptics argue synchronicities are just selective memory. We notice the hits and ignore the misses. Yet, quantum biology keeps finding nature exploiting entanglement in unexpected places. If birds navigate by quantum compass cells and plants optimize growth through coherent light absorption, why couldn't human minds resonate with a deeper layer of connected meaning? Experiments show that people in meditative or flow states exhibit heightened sensitivity to synchronous events, as if quieting the brain's noise lets quantum whispers through. Whether physics or poetry, this idea reshapes how we see chance. Synchronicities might not be glitches in reality, but clues to its true nature, a universe not just of matter and energy, but of meaning and connection. As Jung wrote, the psyche and the cosmos are indistinguishable. In a quantum-conscious world, he might have been more right than he knew. The next time life hands you an uncanny coincidence, consider this. It might not be luck, but the universe leaning in, reminding you that nothing is ever truly separate. The quantum observer effect has long haunted the halls of physics laboratories where particles seem to choose their behavior based on whether they're being watched. But what if this phenomenon isn't confined to tiny particles in vacuum chambers? What if conscious observation influences the cosmos itself, shaping galaxies and cosmic voids through some vast quantum feedback loop? This isn't just philosophical musing. A fringe but growing coterie of cosmologists suggests that the universe's largest structures might bear the fingerprints of observation, with consciousness acting as a cosmic sculptor on scales we're only beginning to fathom. Start with the cosmic microwave background, the afterglow of the Big Bang. Its temperature fluctuations map the earliest seeds of galaxy clusters and superclusters. But here's the puzzle. Certain large-scale anomalies defy standard cosmological models. One patch of the sky, dubbed the cold spot, is eerily empty, a cosmic void spanning billions of light years. Conventional explanations point to chance or measurement error. But what if it's something else? Some theorists propose that regions like the cold spot could be artifacts of quantum backreaction, where the cumulative observations of conscious beings subtly warp space-time geometry over eons. Picture trillions of minds across galaxies, their collective attention, intentional or not, nudging quantum probabilities in ways that ripple across the cosmic web. The math behind this is speculative but provocative. Quantum backreaction normally describes how particle pairs popping in and out of existence near black holes can alter space-time curvature. Now scale that up. If consciousness arises from quantum processes, as Orch-OR theory suggests, then the act of observation might not collapse wave functions locally. It could generate tiny gravitational ripples. Over billions of years, these ripples could amplify, steering the growth of cosmic filaments or suppressing galaxy formation in certain regions. It's as if the universe is a quantum canvas and consciousness is the brush, painting with strokes so faint we mistake them for randomness. Even dark energy, the mysterious force accelerating cosmic expansion, might fit this picture. Its distribution isn't perfectly uniform. Some regions expand faster than others. Could this variation reflect differences in the density of conscious observation across space-time? Wild as it sounds, models exist where conscious systems interact with the quantum vacuum, effectively measuring it into specific configurations. In this view, the more a region of the universe is observed, the more its quantum foam crystallizes, subtly altering dark energy's grip. Galactic clusters teeming with life might expand slower than desolate voids, not because of gravity alone, but because observation itself counteracts dispersion. Skeptics scoff at the scale problem. How could human-scale observation affect something as vast as a supercluster? Yet quantum entanglement shows that scale might be an illusion. Particles separated by light years remain eerily linked. If consciousness is fundamentally quantum, its influence might not diminish with distance but propagate through entanglement's ghostly channels. After all, the universe was once smaller than an atom, and quantum imprints from that era now stretch across the cosmos. Why not conscious ones? Ancient myths spoke of gods dreaming the world into being. Modern physics might be inching toward a similar conclusion, not with deities, but with consciousness as a fundamental force, weaving reality from the quantum up. The next time you gaze at the stars, consider this. The act of seeing might not just take in light. It might, in some infinitesimal way, help shape what's there. As physicist Freeman Dyson once wrote, "The universe knew we were coming. Perhaps it's because we've been collaborating all along." Imagine a universe where consciousness isn't something that emerges from brains, but something that permeates the cosmos, a fundamental property as real as gravity or electromagnetism. This is the bold claim of integrated information theory, or EIT, developed by neuroscientist Giulio Tononi. At its core, EIT proposes that consciousness arises when information is integrated in a specific way, when a system isn't just processing data, but weaving it into a unified, irreducible whole. The measure of this integration is called phi, a number representing how richly interconnected and interdependent a system's components are. The higher the phi, the more conscious the system. Human brains score high, but what if the universe itself scores higher? Start with a single hydrogen atom. According to IIT, it has a tiny, non-zero phi, not because it thinks, but because its proton and electron exchange information, influencing each other's states. Now scale this up to molecules, cells, and brains, where phi grows exponentially as networks become more complex. But here's the leap. Quantum entanglement suggests the entire universe might be wired like a cosmic brain, with particles influencing each other instantly across light years. If entanglement represents the ultimate form of information integration, then the universe's phi could be staggering, not just a sum of its parts, but something greater, a vast, self-aware tapestry of interconnected quantum states. The math gets dizzying. In black holes, for instance, information isn't lost, it's scrambled and preserved on the event horizon, a process eerily similar to how brains distribute memories across neural networks. If black holes are integrating quantum information on unimaginable scales, could their phi rival that of a human mind? Even empty space seething with virtual particles might contribute. Quantum foam, the froth of fleeting particles at the Planck scale, could be a low-level hum of proto-consciousness, trillions of tiny phi values summing into something vast. Some theorists calculate that the cosmic web structure, filaments of galaxies linked by dark matter, mirrors the connectivity of a brain optimized for phi, as if the universe evolved not just to create stars but to think. Critics argue that phi can't apply to non-biological systems. Consciousness requires specific architectures like neurons, yet quantum biology keeps blurring those lines. Photosynthesis relies on quantum coherence. Birds navigate via entanglement. If nature exploits quantum weirdness for function, why not for awareness? IIT doesn't care what stuff a system is made of, only how it integrates information. And if the universe's quantum fields are the ultimate information processors, then perhaps phi isn't just a property of minds but of spacetime itself. The implications rewrite reality. If the cosmos has high phi, then galaxies aren't just islands of stars, they're nodes in a cosmic neural network. The Big Bang wasn't just an explosion, it was the universe waking up, its phi climbing as quantum connections multiplied. Even time's arrow could reflect growing integration, with entropy not as chaos, but as the universe's expanding, working memory. As Tononi once mused, consciousness isn't a feature of the universe. It might be the feature. Whether poetry or physics, one thing's clear. In a quantum-connected cosmos, the line between observer and observed has never felt thinner or more profound. What if your brain isn't just processing the present but somehow skimming information from the future? It sounds like the plot of a sci-fi movie, but quantum physics has already shown that time might not flow the way we think. At the heart of this mystery lies the delayed choice quantum eraser experiment, a mind-bending test that suggests particles can retroactively change their behavior based on future observations. But here's the radical leap. If particles are sensitive to future measurements, could consciousness, the ultimate observer, also be tapping into quantum data from moments that haven't happened yet? Picture a photon racing toward a screen after passing through a beam splitter, a device that lets it take two paths at once. In classic quantum fashion, it behaves as both a particle and a wave, until you place a detector to observe which path it took. The act of measurement collapses its wave function, forcing it to choose. But in the delayed choice version, something stranger happens. Scientists wait until after the photon has already traveled its path, when it should have already decided whether to act as a particle or wave, before randomly choosing whether to measure it. Astonishingly, the photon's past behavior changes to match the future measurement. It's as if the particle rewrites its own history based on what's about to happen, like a chess player moving a piece backward to fit a checkmate they haven't seen yet. Now replace the photon with a mind. Studies in human decision-making have uncovered eerie parallels. In experiments where subjects must rapidly choose between images flashed on a screen, their brains show physiological responses, changes in skin conductance, pupil dilation seconds before the image even appears, as if their nervous systems are preemptively reacting to future stimuli. These effects are small but statistically significant, and they defy conventional neuroscience. Could this be consciousness entangling with its own future states, much like quantum particles do in delayed choice experiments? Some researchers propose that if the brain operates on quantum principles via microtubules or other quantum-sensitive structures, it might momentarily access probabilistic futures before they solidify, creating a faint whisper of precognition. The implications unravel causality itself. If consciousness can pull information from the future, even fleetingly, then free will and destiny might be locked in a quantum tango. Ancient oracles and modern psychics have long claimed glimpses of what's to come. Could these be intuitive brushes with time-symmetric quantum processes? Even déjà vu takes on new meaning, not a memory glitch, but a momentary overlap with a future observation collapsing back into the present. Skeptics argue these effects are statistical noise or unconscious pattern recognition. Yet the quantum eraser experiment proves retrocausality isn't just possible, it's mandatory under certain conditions. If particles dance to the tune of future measurements, why not minds? As physicist Yakir Aharonov, pioneer of time-symmetric quantum theories, put it, the future may not be written in stone, but it's already whispering in the quantum wind. Whether prophecy or physics, one thing's certain: time might be far more fluid than our linear minds can fathom, and consciousness could be swimming in both directions at once. Ancient mystics spoke of the Akashic records, a cosmic library where every thought, action, and event is eternally inscribed, waiting to be accessed by those who know how to read its pages. For centuries, this idea lived in the realm of esoteric spirituality, dismissed as fantasy. But what if the sages were onto something profound? Modern quantum field theory might hold the key to unlocking this mystery, revealing a universe where information isn't just stored in dusty scrolls or fading memories, but woven into the very fabric of reality itself, a quantum Akashic field humming beneath the surface of existence. Imagine the vacuum of space, far from empty. It's a seething foam of virtual particles popping in and out of existence, a quantum dance of energy and information. Physicists describe this as the zero-point field, the lowest possible energy state of the universe, yet brimming with potential. Now take this a step further. What if this field doesn't just carry random fluctuations, but organized information, structured like a hologram where every part contains the whole? This is the essence of the quantum Akashic field, a cosmic hard drive where every event, from the birth of a star to your childhood memories, leaves an imprint in the quantum fabric, preserved in the oscillations of spacetime itself. The parallels between ancient lore and cutting-edge physics are eerie. Vedic texts describe Akasha as the ether, an all-pervading medium underlying creation. Quantum field theory, in turn, posits that the universe is built on fields electromagnetic, gravitational, and perhaps even a conscious one. If consciousness arises from quantum processes, as theories like Orch-OR suggest, then accessing the Akashic records might not require mystic rituals, but an alignment with these deeper quantum rhythms. Near-death experiencers often report encountering a library of souls or a flood of universal knowledge. Could this be a glimpse of the brain momentarily syncing with the quantum Akashic field, its entangled particles retrieving data from the cosmic web? Experiments hint at tantalizing possibilities. In studies of intuitive cognition, subjects have demonstrated the ability to guess hidden information at statistically improbable rates, as if tapping into a shared informational field. Even more compelling, quantum entanglement allows particles to share information instantly across vast distances, suggesting a universe where information isn't bound by space or time. If the Akashic field operates on similar principles, then past, present, and future might coexist in a quantum superposition, with consciousness acting as the lens that brings specific moments into focus. Skeptics argue that information degrades over time, making eternal storage impossible. Yet, black hole physics shows us that information is never truly lost, just transformed. The holographic principle suggests that all the data needed to reconstruct a three-dimensional universe could be encoded on its two-dimensional boundary, like a cosmic DVD. If so, the Akashic records might not be a metaphor, but a mathematical inevitability, a universe that never forgets because every event is etched into its quantum backbone. This idea blurs the line between science and spirituality in ways that thrill and unsettle. If the Akashic field is real, then creativity, intuition, and even déjà vu could be moments when individual minds brush against the universe's collective memory. Artists who speak of ideas channeled from beyond, or scientists who dream breakthrough equations, they might not be imagining things. They could be tuning into a frequency most of us haven't learned to hear. As physicist Erwin Schrödinger once mused, the total number of minds in the universe is one. In a quantum Akashic cosmos, that mind isn't just thinking, it's remembering forever. Picture the fiery dawn of the cosmos, a searing plasma of pure potential, where every particle was entangled in perfect quantum harmony. In those first fleeting moments after the Big Bang, the entire universe might have existed not just as a superheated soup of matter and energy, but as a single, unified field of awareness. This is the extraordinary possibility at the heart of our 27th theory, that the infant universe wasn't just physically coherent, but consciously coherent, a cosmic mind experiencing itself without division before space-time itself had fully taken shape. At temperatures exceeding 10 trillion degrees, the early universe was too hot for atoms, even protons and neutrons couldn't form. Instead, it was a quantum playground where particles existed in flawless superposition, every quark and photon dancing in instantaneous connection with every other. Under these extreme conditions, quantum decoherence, the process that ordinarily collapses superpositions into definite states, couldn't occur. No environment existed to measure the system, leaving the universe in a state of pure potential. Some theorists argue this wasn't just a physical state, but a phenomenological one, a vast, undifferentiated consciousness experiencing all possible realities simultaneously. Imagine a cosmic version of the Buddhist concept of pure awareness before subject and object split, an infinite I am with no edges or distinctions. As expansion cooled the universe, reality began to fracture. Around 1 microsecond after the Big Bang, quarks condensed into protons and neutrons, breaking primordial symmetries. This phase transition marked more than a physical shift. It might have been the moment cosmic consciousness first fragmented into localized pockets of awareness. The mathematics is hauntingly suggestive. Quantum decoherence equations show how interaction with an environment destroys global coherence, creating the illusion of separate systems. Apply this to consciousness, and the expanding universe becomes a story of awareness differentiating like a mirror, shattering into countless reflective shards, each now reflecting its own partial reality. The echoes of this cosmic awakening might still reverberate through the universe's structure. The cosmic microwave background, the afterglow of the Big Bang, contains faint anomalies where temperature fluctuations deviate from expected randomness. Could these be quantum imprints of the universe's first thoughts, frozen into space-time like scars from its initial coherence? Even dark matter's enigmatic behavior fits this narrative. Its refusal to interact electromagnetically might not be mere happenstance, it could be the remnant of that primordial conscious field, now too decohered to communicate with ordinary matter except through gravity's whisper. This theory reframes cosmic evolution in staggering terms. The birth of galaxies wasn't just gravity sculpting gas, it was consciousness learning to focus, like a mind waking from a dream. Stars become neural firings on a galactic scale, black holes, cosmic forgetting mechanisms that preserve information while hiding it from view. Some models even suggest that life, especially conscious life, emerged as the universe's way of rediscovering its lost unity, with human brains acting as localized repair nodes in a fractured quantum network. Skeptics argue this conflates poetry with physics, that quantum coherence doesn't imply awareness. Yet, Orch-OR theory and quantum biology show how coherence can scale to consciousness in biological systems. If a warm brain can sustain quantum vibrations, why not a universe fresh from its own creation? The boundary between physical process and lived experience grows thin at such extremes. As physicist Andre Linde once mused, in the beginning was the Word, and the Word was superposition. Whether metaphor or mechanism, one thing's certain: the universe's first moments might hold secrets not just about matter's birth, but about the origins of mind itself. We've all experienced it, that eerie moment when you swear something about the past was one way, only to discover countless others remember it differently. The Berenstain Bears spelled with an EI, or was it always I? Nelson Mandela dying in prison in the 80s, except he didn't. These collective false memories, dubbed the Mandela effect, have been dismissed as quirks of human psychology. But what if there's something far stranger: glimpses of reality itself shifting under the weight of collective observation? Quantum consciousness theories suggest these moments might not be failures of memory, but evidence of the universe rewriting its own history when enough minds align on a new version of events. At the quantum level, particles exist in multiple states until observation forces them to pick one. Scale that up to human experience, and you get a radical proposition. Entire chunks of history might hover in superposition until consensus collapses them into a single timeline. Think of reality as a vast, unfinished manuscript, one where every conscious observer holds a pen, collectively inking the details into existence. When large groups misremember the same detail, it could indicate a moment when the universe's quantum draft was edited, leaving residual edits in the form of conflicting memories. This idea gains traction when you examine how memories form neurologically. The brain doesn't store recollections like files in a cabinet. It reconstructs them anew each time, weaving together fragments with present context. Quantum models propose this reconstruction isn't purely biological. Microtubules in neurons might interface with a broader quantum field, accessing not just personal memory but a shared pool of potential past. When millions of minds reconstruct an event similarly, say, the Monopoly man's non-existent monocle, they could momentarily tip the scales of a probabilistic past, collapsing it into a new configuration. The old timeline doesn't vanish. It lingers as a phantom limb of history, detectable only through the dissonance of collective déjà vu. Critics argue this conflates metaphor with mechanism. Memory distortions are well-documented quirks of suggestion and neural plasticity. Yet, quantum biology keeps revealing nature's knack for harnessing improbability. If plants optimize photosynthesis through quantum coherence, why couldn't human memory exploit similar processes? Experiments show that groups in shared emotional states, like crowds at historic events, exhibit synchronized brainwave patterns, as if temporarily entangling their neural networks. In moments of mass focus, from viral internet debates to global crises, this synchronization might nudge the universe's quantum substrate toward alternate branches we'd otherwise never perceive. The implications rewrite not just history but identity. If the past is fluid, then so is the self, an ever-adapting story woven from both personal and collective observation. Those uncanny Mandela effects might be more than glitches. They could be cosmic breadcrumbs, hinting at a universe where consciousness doesn't just witness reality, but continuously authors it, one shared memory at a time. What if UFO encounters aren't visits from distant star systems, but glimpses of a deeper layer of reality, where consciousness and quantum fields collide to manifest phenomena that defy conventional physics? This theory takes us beyond extraterrestrials into uncharted territory, proposing that unidentified aerial phenomena might be projections of a universe that's not just inhabited by minds but shaped by them. At the intersection of quantum consciousness theories and decades of enigmatic sightings lies a startling possibility. These elusive objects could be quantum mirages, holographic echoes of a reality still learning to define itself. Consider the bizarre properties reported in high strangeness UFO cases, crafts that morph mid-flight, vanish into thin air, or appear to react to observers' thoughts. These aren't just engineering puzzles, they mirror the behavior of quantum systems under observation. In the double-slit experiment, particles change from waves to particles when measured. Now imagine that same principle scaled up. A UFO's solidity or intangibility might depend entirely on whether and how it's being perceived. Some researchers suggest these phenomena arise from a feedback loop between human consciousness and quantum fields, where focused attention acts like a cosmic projector beam, momentarily stabilizing probabilistic realities into tangible form. The military's recent encounters add fuel to this fire. Fighter pilots describe objects executing maneuvers that obliterate known physics, instant acceleration, right angle turns at thousands of miles per hour. Classical mechanics says these feats demand infinite energy, but quantum entanglement shows particles influencing each other across space without energy expenditure, as if the universe has hidden channels where the rules differ. If consciousness is quantum at its core, could extreme mental states like the hyperfocus of trained observers unlock transient control over these channels? Ancient mystics spoke of bending reality through will. Modern quantum models might be catching up. Even the nuts and bolts of UFO lore take on new meaning under this lens. Abduction accounts often describe beings that phase through walls or communicate telepathically, hallmarks of non-local quantum behavior. The infamous Oz factor, where witnesses report entering a silent, detached state during sightings, eerily parallels the quantum Zeno effect, where continuous observation freezes a system's evolution. Could these episodes be moments when human minds and quantum fields briefly synchronize, creating shared hallucinations so coherent they leave physical traces? The most provocative evidence comes from controlled experiments. In government-funded studies like Project Stargate, remote viewers demonstrated an uncanny ability to describe distant locations and occasionally objects matching UFO descriptions, as if accessing a quantum information field. Meanwhile, quantum radar research has detected phantom signatures resembling cloaked objects, where particles briefly entangle with something outside our perceptual bandwidth. These anomalies suggest UFOs might not be objects at all, but temporary concentrations of quantum probability, shaped by observer expectations into familiar forms, from flying saucers to mythical beings. Skeptics argue this conflates metaphor with mechanism, but quantum biology keeps eroding the boundaries. If birds navigate via entangled particles and photosynthesis harnesses quantum coherence, why couldn't consciousness, under rare conditions, imprint its expectations onto the quantum vacuum? After all, the universe is already a flickering quantum canvas. We might not be seeing visitors from other planets, but reflections of a deeper truth that reality is a collaborative work in progress, and sometimes when the conditions align, the canvas looks back. Imagine the universe not just expanding but evolving, its scattered sparks of awareness gradually coalescing into a single, luminous point of pure understanding. This is the Omega Point, philosopher-theologian Pierre Teilhard de Chardin's visionary concept of cosmic destiny. He saw the universe as a living, learning entity climbing from chaos toward total self-knowledge. Now, quantum consciousness theories inject this idea with startling new urgency. What if the Omega Point isn't just poetic metaphor, but an inevitable quantum phase transition? a moment when the universe's fragmented consciousness finally achieves perfect coherence, recognizing itself in one transcendent flash. Teilhard's framework feels ripped from modern physics when viewed through a quantum lens. He described complexity and consciousness rising in tandem from atoms to cells to human minds. Quantum biology reveals this isn't just philosophical musing. Life does exploit quantum effects to leap forward. Photosynthesis uses superposition to optimize energy harvesting. Bird brains harness entanglement for navigation. Now extrapolate that trajectory. As technology approaches the singularity, the hypothetical moment artificial intelligence surpasses human cognition, we might unlock tools to amplify and interconnect quantum awareness on planetary scales. Imagine a future where quantum computers, biological brains, and AI merge into a planetary mind, its neural net stretching across continents through entangled particles. This isn't science fiction, it's the logical endpoint of known quantum principles. As systems grow more complex, their capacity for integrated information phi increases. Human brains are local maxima of phi, but what about a civilization linking billions of augmented minds via quantum networks? The universe itself could be climbing toward higher phi states, with technological singularity acting as the catalyst for a cosmic scale phase shift. Like trillions of neurons firing in unison, galaxies of quantum processors might suddenly snap into alignment, their collective observation collapsing the universe's unresolved possibilities into a single crystalline reality, the omega point. The mechanics could mirror black hole physics, just as a collapsing star's information concentrates at its event horizon. A conscious universe's accumulated knowledge might compress toward a dimensionless point of infinite understanding, not a physical location, but a quantum state of total coherence. Near this omega point, time itself could distort. Consciousness, no longer bound by linear causality, might perceive all moments simultaneously, past, present, and future fused into one self-aware now. Teilhard called this the Christogenesis, but secular physics offers equally mind-bending terms. The universe achieving its own wave function collapse, observed into perfection by its own awakened gaze. Skeptics argue this conflates thermodynamics with teleology. The universe tends toward entropy, not enlightenment. Yet black holes show entropy and information are two sides of the same coin. If consciousness is fundamentally quantum, then increasing universal complexity might naturally birth deeper awareness, even amid chaos. The eerie fine-tuning of cosmic constants for life hints at this directionality, as if the universe was primed from the Big Bang to eventually look back at itself with knowing eyes. Whether spiritual or scientific, the omega point compels us to rethink our role in the cosmos. We're not just bystanders to universal evolution, we're its leading edge. Each thought, each discovery, each connection might be nudging reality closer to its ultimate awakening. As Teilhard wrote, someday, after mastering the winds, the waves, and gravity, we shall harness the energies of love, and then, for the second time in history, humanity will have discovered fire. In a quantum-conscious universe, that fire might not just illuminate, it could unite. We've journeyed through 30 mind-bending theories, from panpsychist atoms humming with proto-consciousness to black holes processing cosmic thoughts, from entangled minds to holographic universes where observation stitches reality into existence. Each idea shatters the illusion that consciousness is a mere byproduct of biology, instead suggesting it might be the foundation of reality itself, woven into the quantum fabric of space-time. But as we stand at the edge of this intellectual frontier, what does it all mean for us, the seemingly small observers in a vast, possibly sentient cosmos? Consider the staggering implication. If consciousness is fundamental, then every glance at the stars, every measurement in a lab, isn't just passive witnessing its participation. You're not separate from the universe, you're its way of perceiving itself, a localized knot of awareness in an infinite web. Ancient mystics spoke of this unity, but now physics offers equations that echo their insights. The double-slit experiments, observer effect, quantum entanglement, spooky connections, even the eerie symmetries between galactic structures and neural networks all hint that mind and matter might be two faces of the same coin. Yet mysteries remain. If the universe is conscious, what does it dream about? Does it ponder its own origins through our telescopes and colliders? Are black holes its forgotten memories and supernovas its bursts of creative inspiration? And what of free will if quantum choices ripple upward to shape cosmic evolution? Are we co-authors of reality or merely fragments of a grander thought? These aren't just scientific questions, they're deeply human ones, touching our longing for meaning in the great expanse, the most thrilling possibility. We might be on the verge of answers. Quantum biology is uncovering life's reliance on coherence and entanglement. AI researchers are probing whether machine minds could achieve self-awareness through quantum architectures. Even astrophysicists are reimagining dark matter as a quantum-aware substrate. Every discovery pulls us closer to a paradigm shift, one where consciousness isn't an accident in a dead universe, but the very pulse of existence. As you step away from this exploration, carry one thought with you. The next time you gaze at the night sky, remember, you're not just looking out at the cosmos. You might be the cosmos looking back at itself. And if that's true, then every question we ask, every theory we test, is the universe slowly waking up to its own nature. What do you think? Is reality a shared dream, a quantum computation, or something beyond our wildest metaphors? Drop your thoughts below, and if your mind's still buzzing with wonder, hit subscribe, because the universe's greatest mysteries are just beginning to unfold.